Hello everybody, Fengkai speaking here. And my topic today is end-to-end WANaaS. First, a little bit about myself. I'm a staff from Huawei Technologies, and I have been working in telecommunication for nearly 10 years. I'm currently focusing mainly on future network, SDN, and I'm active in open source community and standard organizations. The motivation and goal of E2E WANaaS is to enable the automation of end-to-end WAN connectivity and embedded value-added service customization and provisioning on demand. We see that the cloud, data center, enterprise applications, or self-service subscribers describe their end-to-end networking service requirements among their user endpoints in a subscriber-friendly way. They focus mainly on the service attributes. They don't care about the networking technology or the detailed network configurations. Moreover, the connectivity between the user endpoints may span over one or multiple domains, so the inter-domain topology is needed for inter-domain path selection and service segmentation. This is a scenario for E2E WANaaS. We can see that three kinds of connections between user endpoints. They focus on different service attributes such as the bandwidth isolation, cost, and latency. And also we can see that they span one or multiple domains. This is a design for the E2E WANaaS, a whole picture. The subscriber or the applications may use the user-centric NaaS service model to describe their service requirements. The E2E WANaaS will map the user service models to the WAN network resource control models. And finally, the networking service will be deployed on the underlying networks. This is the essentials of E2E WANaaS. Service instance, it may be a connective service with embedded value-added service, or it may be a user experience monitoring service. The user endpoints to be connected. Service attributes, which is expressed in the form of service contracts. Inter-domain topology instance for the inter-domain path selection and service segmentation. Mapping logic instance for mapping the requirements from one service model to one network resource control model. User-centric NaaS service instance is used for the customization and description of users' networking requirements. It has the following attributes. The list of UEPs is for the user endpoints to be connected via the connecting service with service type, which may be point-to-net, point-to-point, multi-point to multi-point, or routed multi-point. The service contract is for the service attributes. It may have the basic service attributes as well as value-added service. For the value-added service, it is an event, classifier, and action tree tuple pattern. The user experience monitoring instance is used for the testing of users' experience between the source user endpoint specified by the source ID and the destination user endpoint specified by the destination ID. The user can also specify the test type and the type of experience, such as the readability, load ratio, IP, TCP, UDP, HTTP, delay variation, and so on. This is the inter-domain topology instance. Each domain is abstracted as a virtual node with two kinds of ports. The first kind of port is UNI, user network interface, which connects to the user endpoints. And the second kind of port is ENI, external network-to-network interface, which connects to other domains. So you can see there are two main attributes in the inter-domain topology instance, the UNI to ENI path and ENI to ENI path. This is a architecture design for the E2E WANaaS Orchestrator. We had a name for this orchestrator. We named it Grace. you can see all the components within Grace. In the middle is a queue, which is for the message exchanging between the models within Grace, and Grace database for the data storage. Oh, sorry. For the Grace API and northbound verifier, which is used for the APIs provided by Grace, and southbound agent and southbound verifier is used for the connection between the Grace and the controllers. Other components within Grace are mainly for the handling of the service attributes when the application or self-service subscriber describes their network service requirements. Oh, sorry. This is the status of the E2E WANaaS. We have 3 blueprints in Neutron, and the demo is ready for the proof of concept, and open source code is being contributed. And finally, I want to show you a demo of E2E WANaaS. Suppose a company has 3 branches located physically separately, such as in Beijing, Xi'an, and Guangzhou. Each branch has 3 departments: product department, OM department, and customer department. They want to connect their product department through a multi-point to multi-point service, and so is for their OM department. And for their customer department, they want a routed multi-point connecting service, which means the customer department in each branch can communicate with the product department in Guangzhou, but they cannot communicate with each other. And finally, the product department in Beijing can communicate the OM department in Xi'an. This is the final service graph by the 4 basic service instance. So, and last, I want to show you the demo. And this is the portal for the Grace. We can log in with demo and password. And this is the portal for the OpenStack. From the portal of OpenStack, we can see that there is no network resource allocated. Then we will customize the service requirements with the Grace portal. First, we do the UEP allocation and domain configuration, and we can check the domain topology within Grace portal and also in the OpenStack portal. Okay, this is the final complex service graph that the company wants to describe with E2E WANaaS. First of all, we will configure the routed multi-point video service. We add the value-added service with ECA. If the delay is bigger than 2 milliseconds, we will block 1 personal PC. This is submitting the request, and we can check the results. It is accepted. Then, with the same way, we add the other 3 services. We can see that they are all accepted. And this is a service graph, and the compiling results for the complex service graph. And also we can check each basic service graph for each service instance and the networking information. Okay, we suppose the service starts at these days, and we will see the results from the OpenStack portal. We can see that all the services have been deployed. Then at this date, some service ends, we can see that the resource is recycled from the OpenStack portal. And finally, we will do the testing for the routed multi-point service. We add 4 virtual machines. We can see that the customer 1 from the product department can connect to the customer 1 and customer 2. So it's for the virtual machine VM20. Also, the customer can connect to the user endpoints in the product department. Then the traffic congestion happens. We can see that the delay between the user endpoints is much bigger than the 2 milliseconds. This is the dashboard. Then with the value-added service handling, there should be a rule for the firewall within the OpenStack. We can see that the packet from that IP address should be denied. Then VM100 cannot connect to either customers. But the other virtual machine 20 can connect to the two customers. Then the delay fixed. We can see that the delay and from the dashboard. And from OpenStack portal, we can see that the firewall rules has been deleted. And finally, with the ping, we can see it has been fixed. Then finally, the routed multi-point video connection should be deleted, and the network resources should be recycled. All these connectivity services has been recycled. Okay, that's all. Thank you.